Hello everyone, welcome to Reactify Labs. Today we will talk about Redis and Memcached. Redis and its Memcached. No, what happened? You must have heard about them that these are used when we need caches. So let's go into detail of where Redis can be used, where Memcached can be used, what's the fundamental difference between Redis and Memcached, why sometimes we cannot use Memcached, and why sometimes it's better to use Memcached than Redis, and things like these. Okay. So let's define the structure that we are going to discuss today. First, we will start with the introduction of Memcached. Then we will talk about the features of Memcached. Then we will talk about the architecture of Memcached. Next, we will see what are some of the common commands of Memcached and their usage. And then we will see what are the drawbacks or shortcomings of Memcached. After this, we will start with the introduction of Redis. We will talk about the features, architecture, and what are its advantages over Memcached. Okay, and then we will conclude with when to use what. When to use Redis and when to use Memcached. Okay, so now the structure is clear. Let's start with the introduction to Memcached. So Memcached is basically a combination of two words, memory and cached. Memcached is a robust, high performance and distributed memory caching system. Okay, so it's a robust and high performing distributed memory caching system. It is designed to accelerate dynamic web applications by efficiently caching frequently accessed data in memory. It acts as a fast and accessible layer, reducing the load on backend databases. It finds application in various scenarios, including web caching, to speed up content delivery, session storage for quick retrieval of user specific data, and any situation demanding rapid access to information. Okay. Now let's see what are some of the key features of Memcached. Just to clarify, I'll start with the heading Memcached. So these all come under Memcached. So first feature is in-memory caching. Memcached employs in-memory caching, storing data in RAM. This approach significantly reduces data retrieval times, making it an optimal choice for scenarios where speed is crucial. That's the primary advantage of in-memory caching, right? When you prefer speed over storage, right? You prefer in-memory caching because that's the fastest way. Next is distributed architecture. Memcached is designed with a distributed architecture, allowing it to be deployed across multiple nodes. This inherent scalability supports load distribution and ensures efficient utilization of resources. And next is simple key value model. So Memcached follows a straightforward key value storage model. Data is stored with a unique identifier called key and can be easily retrieved using that key, just like what we do in maps. This simplicity enhances ease of use and integration with various applications. So this simple key value model is what makes Memcached very simple and fast. And since we don't have complex support, it means it's, uh, it's good for storing if you have simple data which you can just fetch using a key. Okay, if you have a data storage like key value, so for caching such kind of data, Memcached is a good choice. Okay, now let's talk about the architecture of Memcached. Memcached excels in distributed caching. Okay, first point comes is distributed caching. Memcached excels in distributed caching, a technique where cached data is spread across multiple servers or nodes. Each node within the Memcached cluster holds a portion of the overall cached data. Okay, so there will be different nodes because it's a distributed architecture and data will be spread across different servers, and each node within the cluster holds some data. Not all the data will be there in one node. Okay, and what will be the advantages of distributed caching? Obviously, improved performance. We have talked about the advantages of distributing something so much in this series that it should be by heart to the viewers now. Okay. Uh, so why improve performance? Distributed caching, distributing cache data across nodes enhances overall system performance by reducing the load on individual servers. This ensures that each node handles a fraction of the total requests, preventing bottlenecks. Second comes enhanced fault tolerance. With data distributed across multiple nodes, the system becomes more resilient. In the event of a node failure, other nodes can still serve data, preventing a single point of failure. And next is scalability. The distributed caching model supports horizontal scaling. As the demand for caching capacity increases, new nodes can be seamlessly added to the Memcached cluster. This approach allows the system to grow and handle large volumes of data and requests. Okay. Next, if it's distributed, we need something called consistent hashing. Okay. Memcached uses consistent hashing. Memcached uses consistent hashing as part of its distributed caching strategy. Consistent hashing ensures a stable mapping of keys to nodes, even when the number of nodes change. This consistency is crucial for maintaining a balanced distribution of cache data. If it's not clear, I'll explain again. So, as we said, there will be a key value kind of storage in Memcache, right? Now, these keys and value is corresponding to key, right? Value is dependent on key. So, let's talk about only key now. These key will be distributed on different nodes, right? And we just talked that it has a distributed architecture, and if it has distributed architecture, it means there are different nodes. And to avoid skewed distribution of the keys, the distribution algorithm that we follow is consistent hashing. Similar thing we do in load balancing. If you don't know what load balancing and consistent hashing are, I suggest please go back and watch that video. I have made two separate videos, one on load balancing and one on consistent hashing. One video is completely dedicated to consistent hashing. I assure you it will clear all your doubts about consistent hashing. So please go and watch it if you don't already know it. If you know it, well and good. So that's why we use consistent hashing for distributing keys on different nodes, which makes the performance of Memcached really good. Okay. So next, in the architecture, we will talk about the scaling. Okay. Next thing comes is scaling. It has horizontal scaling. Okay. Memcached achieves scalability through horizontal scaling, a process of adding more nodes to the cluster. Each node contributes to the overall performance and storage capacity of the Memcached system. As we talked here that it has distributed architecture means it will have nodes on different data, data on different nodes. Now let's say all these nodes are full and we need to add more data. What will we do? We will just add a new node, and if that is full we will just add a new node. This is what horizontal scaling does, right? So this is obvious from here. When we say that data is distributed in different nodes, it means obviously it is doing horizontal caching and obviously load balancing on different nodes, and we are using consistent hashing to distribute those nodes. When new nodes are added to the memcache cluster, the system dynamically redistributes the load. This ensures that the increased demand for caching resources is evenly distributed among all nodes, preventing overloading of specific servers. If you recall from the video of consistent hashing and load balancing, you will see that if there are, let's say, 4 nodes and keys are distributed or data is distributed on these nodes, and if we add one more node, let's say, so all these nodes data need to be redistributed. And for the most efficient distribution, we know an algorithm called consistent hashing. So if we use consistent hashing, this redistribution of data will be very less. So let's say earlier we had to, let's say we had 100 data and a new node came, 100 data on four nodes. Now we have to distribute 100 data on 5 nodes. Let's say by using other algorithms, if we had to redistribute 80 data points, with consistent hashing we may have to redistribute, let's say, only 20 data points. So that's why consistent hashing is used. Okay, so when we have to do scaling, we do horizontal scaling due to the distributed nature of the memcached architecture, and we do load balancing. For that we use consistent hashing so that the number of rebalances, the number of redistributions will be less. Okay, and next is elasticity. Horizontal scaling provides elasticity to the memcached infrastructure. The ability to scale up or down based on demand allows the system to adapt to changing workloads, maintaining optimal performance during peak usage periods, right? Again, the same thing, 4 nodes. If let's say load increases, we will add one more node. If let's say load does not increase or it decreases, then we may give rest to one node. Okay. And again, if we are bringing back or bringing down the number of nodes from 4 to 3, again we have to redistribute all these data to 3 nodes, right? For these, again we will have a lot of redistribution if we don't follow consistent hashing algorithm. Okay, so that's all there is about the architecture. Now let's see the commands and what these commands do in memcached. So I'll write it here. Memcached commands. Memcached operates with a set of fundamental commands for data retrieval and manipulation. First one is get command. Get retrieves data as you know, like what does get do in REST, in HTTP calls? What does get do? It retrieves data. That's what it does here also. If there is a name which is familiar, which you are familiar with, please, not please, you can assume that it will more or less do the same thing which you already know. So let's quickly finish it. So what will get do? It retrieves data based on a specified key. So you will specify a key with the get function and it will give you the value. There is a set. What it does? It will set the value. Store data in the cache with a specified key. Next is add. It adds data to the cache only if the key does not already exist. Okay. You might ask, what's the difference between set and add then? So what set does is set sets that, okay, this key will have this value, but now this entire thing needs to be stored in the cache. This is what add does. Next is replace. Replace existing data in the cache with new data. Next is append. Sorry, it's 5. Append data to the end of an existing value. Next is prepend. Prepend data to the beginning of an existing value. And last one is delete. It removes data from the cache based on the specified key. Let's talk about some of the usage scenarios where this mm, memcached is used. Usage scenarios. First one is web caching. Memcached is commonly employed for caching frequently accessed web content. This accelerates web applications by reducing the need to fetch data from backend storage on every request. Next is session storage. Memcached serves as an efficient solution for storing and managing session data in web applications. It enables quick access to session related information and load reduction on databases. By caching query results and frequently accessed data, Memcached helps reduce the load on backend databases, improving overall system performance. So if there are some frequently accessed queries, so Memcached cache those results. Okay. Now let's see what are the drawbacks of Memcached, or what are the shortcomings. What is something that Memcached cannot do? So drawbacks or shortcomings. First one is lack of persistence. In-memory cache, because of the in-memory cache, that's the nature of the in-memory cache, and that's the challenge with the in-memory. Actually, anything which is in-memory, it's not persistent. So memcache is designed as an in-memory cache, right, which offers high-speed data access, but this comes with a trade-off. It means data is not persisted to the disk. In the event of a restart or shutdown, cache data is lost, right? That's why we write data to disk what we don't want to get lost. But if memcached starts writing data to the disk, it defeats the overall purpose of memcached, right? So if the data, whatever data is here in the memcached, it will be lost in case of a restart or a shutdown or any power loss, right? Next, limited data structures. It supports, memcached supports key value model, right? Memcached adheres to simple key value storage model. While it is effective for certain use cases, this simplicity limits support for complex data structures and query operations. And consistency issues. Maintaining consistency is a challenge. In distributed environments, achieving consistency across different nodes can be challenging, right? Memcached focus on speed and simplicity may lead to eventual consistency challenges, especially in scenarios with frequent updates. Okay. Now that we have talked a lot about Memcached, let's start talking about Redis. Redis. We will start with introduction. Redis is an abbreviation for Remote Dictionary Server. As Memcached was for memory and cached, it's Remote Distribution Server. Okay. Redis stands as a prominent open source in-memory data structure store. Okay. It's an open source in-memory data structure store. This designation reflects its primary function of managing and storing various data structures in memory. Redis is purpose-built for high-performance, real-time data storage. Its architecture is optimized for swift access to data structures, making it an ideal choice for applications demanding low latency responses. What are some of the use cases of Redis? Real-time analytics. Redis is employed to swiftly process and analyze real-time data. facilitating quick insights. Second is caching. Its in-memory storage makes Redis an efficient caching solution for frequently accessed data. So yeah, one clarification here, don't assume that Redis is only used for caching. One of the features of Redis is caching, right? Next, leaderboards. For applications requiring the management of scoring or ranking data, Redis can be used. And queues. Redis serves as a high performance message broker also in queue based systems. So Redis can assume the role of a message broker also, right? So let's see what are some of the key features of Redis. Features. First one is, it's like Memcached. It also provides in-memory storage. Redis capitalizes on in-memory storage, ensuring that data resides in RAM. This approach significantly accelerates data access and retrieval, enhancing overall performance. Next is rich data structures. Unlike Memcached, which only supported key value pairs, Redis supports rich data structures. Redis supports an extensive array of data structures, including strings, hashes, lists, sets, sorted sets, bitmaps, and hyperlog logs. This versatility allows developers to choose the most suitable structure for their data. And last, persistence options. Snapshotting actually, which plays a key role in persistence in Redis. So periodic snapshots of data set stored to disk offering recovery points. So if this is Redis, then there is a disk also, and after every certain interval, this periodically, like certain intervals, a snapshot of this is made to the disk so that data which once written to the disk does not get lost, which was not one of the features in Memcached, right? And also it has append only files, a log of every write operation, ensuring durability and data recovery capabilities is provided with Redis. Let's talk about the architecture of Redis. Replication and sharding. It's not just architecture, actually it's architecture related to scaling. Okay, so first, replication and sharding. Redis excels in scalability through features like data replication and sharding. These mechanisms ensure data redundancy and enable horizontal scaling, allowing the system to handle increased loads seamlessly. Next is clustering. Redis cluster introduces automatic sharding and partitioning, offering an integrated solution for scalable and distributed deployments. This clustering capability enhances performance and simplifies the management of large data sets. And also fault tolerance. Redis prioritizes fault tolerance, aiming for high availability even in challenging conditions. This resilience ensures that system remains operational and responsive, minimizing the impact of potential failures. Right? You must know now what all the advantages are of Redis over Memcached. Let's write them down. Advantages over Memcached. What all did we study? Data structure support. Redis has more collection of data structure support than Memcached, which only supports key value storage. Redis provides persistence, which Memcached does not, and Redis has advanced features like pub/sub messaging, transactions, scripting, and these are the things which enhance the capabilities of Redis, right? Also, like this, what do you say? These persistent options, um, periodically snapshotting of the data to the disk, support of these data structures, these all come under the advanced features of Redis, along with, yes, some things which I did not talk about, like pub sub messaging, transactions. Right, what is pub sub messaging, transactions, because I have made another video on, I believe I have made one on publisher subscriber, or if not, I'll make one. One of those statements is true. Okay. You know what transactions are in databases. If you don't know, go watch the video on databases. I have made one on transactions, acid, consistency models. Those things are covered there. I have not made any video explicitly on transactions, but in the acid videos, you will see acid guarantees, how transactions need acid guarantees. So yeah, I'll probably make one on PubSub messaging if I have not already made one. Okay, let's move forward. Let's see when to use Redis and when to use Memcached. So when to use Memcached. Memcached proves to be the ideal solution in scenarios where the primary focus is on either simple key value caching. Memcached excels in basic caching needs, providing lightning fast retrieval of key value pairs and raw speed. It prioritizes raw speed in data access, making it suitable for applications with an emphasis on quick and straightforward caching operations. And when to use Redis? Redis stands out as the preferred choice when addressing more complex requirements and use cases that demand advanced data structures, persistence, and additional features beyond caching. You remember I told you Redis is used also for caching, not only for caching. Okay, so Redis supports a diverse set of complex data structures, which makes it suitable for scenarios where different types of data representation is essential. For applications that require data persistence, Redis offers various options to ensure the durability of stored information. And Redis introduces advanced functionalities, which we talked about, PubSub, transaction, scripting, which makes it a go-to solution for use cases demanding enhanced functionality and versatility. Okay, so yeah, this finishes the video on comparison and contrast between Redis and Memcached. I hope this gives you a good understanding of what is Redis, what is Memcached, when to use what. Now, after watching this video, you will be able to tell in the interview, instead of only saying we will use cache here, you can say we will use Memcached here, or we will use Redis here. And if the interviewer asks, why did you choose to use Memcached, or why did you choose to use Redis, you will be in better position to answer that question from now on. Okay, so yep, that's all there was in this video. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.